Okay, welcome to video 2. Let's keep the ball rolling here. All right, the way I'm going to do this first problem here that you see on your screen, which should be on your template, I'm going to work this out with a lot of detail and a lot of explanation. And then as I move along, uh, it'll be a little bit less. Let me explain one thing that happened to me when I was working through the notes. I felt like I didn't quite have enough space in the middle because you see on the middle of your page, middle bottom, there's that x squared plus 8x equals 100. Kind of ran into that problem. So when I get to the next problem, you might want to work that one out on the back. We'll see, but I want you to get everything in the video into your notes because there's a lot of detail here. All right, so let's solve now. So what they're asking you to do is solve this equation using the method of completing the square because this trinomial might not factor. I don't think it does. Factors of 16 or 16 and 1. There's no way to get negative 14 with that. 8 and 2, no, 8 and 2 won't get negative 14, and neither will 4 and 4. This one cannot be factored, so we don't have a method to solve it. Completing the square at this point is the only thing we could do to actually solve it. And from completing the square comes some valuable information. So let's work it out here. Like I said, I'm going to give you a lot of explaining. Please hit the pause button as necessary when you're getting your notes done in class. Okay, so the first thing that I want to do is calculate what is b divided by 2 squared. That is the magic number to create a perfect square trinomial. Well, in this case, b is equal to negative 14. We'll use the absolute value in this case because when we square it, it's going to become positive. So if I take b, which would be 14 divided by 2, and square that, basically you have 7 squared, which is 49. So I want to look to see if that is a 49. It's not, which means this is not a perfect trinomial square. So before I do anything else, I want to move the existing c, which in this case is 16, to the opposite side. You have to do that first. So I'm going to subtract 16 from both sides. So now I'm left with x squared minus 14x is equal to negative 16. All right, so the next thing I need to do is now add b divided by 2 squared to both sides. Sorry, my b did not look very good there. It's b divided by 2 squared, which I calculated right here as 49. So I'm now going to add 49 to both sides and watch what happens. On the left-hand side, do not mix your terms there. It's minus 14x plus 49. That's equal to, now you got to figure out negative 16 plus 49, that's 33. Okay, now here is what's valuable for us. On the left-hand side, again, I'm going to add a little more detail to the notes. This is now a perfect trinomial square. Because it's a perfect trinomial square, I can now factor that. Okay, so what I want to do next is factor the trinomial into its perfect square. So if I factor x squared minus 14x plus 49, you would have x minus 7 squared. Now all I did is factor it. It didn't change anything, so I don't have to do anything to the other side. I just simply factored it right there. Okay, well now we can solve this, and here's why we love this. Now I'm going to add an extra line that we normally won't write. I'm going to go ahead and rewrite that line again. And for this problem, I'd like you to do it in your notes, even though you would do what I'm about to do. That's 33. You would normally do this on the same line, but for the sake of your notes, so you have something to refer to for step 5 is this. Okay, we're going to square root both sides. All right, I'm going to square root both sides. Now, normally we would do this here, but for the sake of your notes, I'm going to take the square root of this whole side, and I'm going to take the square root of this whole side, because this is basically a perfect square. And if you square root a perfect square, that times itself, that comes out to be x minus 7. The square root of x minus 7 squared is x minus 7, just like the square root of 4 squared was 4. Okay, so in that, I now have this. Now also remember, I forgot to put this in. This needs to be in this line. When you do that square root, on the right-hand side, you now have two solutions. You have plus or minus the square root of 33. All right, well, the square root of 33 is a decimal. It's an irrational decimal. So what you see happens in the book, they sometimes change this to approximately, which is a wavy symbol. And I'm going to round it off. Typically, we'll round these decimals off to 2 place values. Don't forget there's 2 of them. There's plus or minus 5.74. Okay, so here's what I have now. I have 2 values for x. X minus 7 can be 5.74 positive, or x minus 7 can be 5.74 negative. So what we have to do now is we have to divide this into 2 parts. X minus 7 could equal 5.74, and x minus 7 could equal negative 5.74. And you're going to have to solve both of them, because remember, when we find solutions, do you remember what we're finding? We're finding those values where they intercept the x-axis. There could be 2 of them. In this case, there are 2. All right, I add 7 to both sides, and that is equal to, we'll do the math there, that comes out to be 12.74. So that's one solution. And we're going to add 7 to this side here. And that works out to be x equals 1.26. Again, these are rounded off because we had to round it off back there because the square root was an irrational number. All right, so what you found are the solutions are that value and that value there. Where if we were to actually graph this on the calculator or something, those are the values where it would cross the x-axis. Trying to graph that using those points would be quite difficult, and trying to identify those solutions with a graph would be almost impossible without a computer or something. So completing the square is now a way to find those solutions for the really tricky ones that we can't that are irrational numbers like this. So I'm going to stop this one and just start the next one on the next problem. Like I said, the next problem I would suggest you turn over to on the back, as you probably need a little more space, and we'll be right back with that question.